G'day friends, just wanted to make a quick video with regard to a very interesting subject, and it is really going to be titled Go Easy on the Flat Earthers. And the reason I say that is because I'm about to give you an example of why some people that think the earth is flat think the earth is flat. All right, and it has something to do with what's called the z-axis, or as some of my friends in America might call it, the z-axis. So the z-axis is, in the case of this example, is the line of sight between you and an object in the distance. That's the z-axis. Now, the best way to make an example is to find a piece of flat earth. Okay, and it's not easy over land because land is so undulating. There are flat pieces of land like runways and things like that, but they're generally not long enough to really make any observations. So you really have to go over the sea, because the sea is sea level. Okay, it's something that you can measure from. Okay, and it is easy to pick a big distance at the sea. So we're going to look out in this example to some islands, and you're going to see that according to the calculations based off a globe Earth with around about a 4,000 mile radius, you're going to see that we can see something that we just shouldn't be able to see. Okay, so moving into it, into the calculations, basically what happens is they've using the globe Earth numbers that I mentioned before, there should be a curvature of 8 inches per mile squared. Okay, 8 inches per mile squared. So in the first mile, there should be a drop of 8 inches. And in the second mile from where you're standing, there should be a drop of 16 inches. And then the third mile should be 32. Okay, 16 times 2 is 32. And then 64 and 128 inches, and so on, so forth for mile after mile. So we're going to see something that's around about 12 miles, 12.4 miles in the distance here. Okay, and I'm standing around about 8 feet above the sea level, maybe a little bit less even, but I'll call it 8 feet to be conservative. And we punch in the calculation there, 8 feet, and then 12.4 miles, and you'll see that there's about a 16 meters of drop or so. Okay, a little bit more than 16 meters of drop. Now, if we go back to the example, actually just let me play the example and then we'll go back to it.
Here I am at Manly in Queensland, place out the front of Drevison Park here. Okay, so just a particularly clear day. Alright, we're looking at in the distance there, the ports. Okay, you know, they're a fair way away, as you can see, but I'll just zoom in a bit there. And then we'll look out east over the sea. Now I'm virtually at sea level here, okay? I'm about probably 8 feet above the sea level here, okay? Sea level, there's a bit of a rise here, but I'm about 8 feet above the sea level, and I'm just looking out to those islands there, and I'll just use an island in the forefront, and you can see there's like a big sand dune over there that island. And so what we'll do is have a look at that on the Google Maps. There's another island there, and you can see that it ends just there. You can see that on Google Maps. And And then we can see right over in the distance over there, the beginning of another island there. So what we'll do is we'll go to Google Maps and we'll see what the elevation of that knob on the island is there, and whether I should be able to see that from the height that I'm at, according to the Globe Earth Curve Calculator. Okay, so that's probably the point there that we'll use, that one there. Let's have a look.
Okay, so we see that the Amity Point is the name of that knob at the end of the island, and we go to the topographical map, and we see that it's just a little bit over 9 meters above sea level. Okay, and so we punch in the the values into the Earth Curve Calculator, and from 8 feet at 12.4 miles, there's a hidden height of a bit more than 16 meters. So that point being only 9 meters above the sea level, we really shouldn't see it. Okay, because 16 meters at that distance should be hidden from our eyesight. But you can see very clearly that not only can we see the top of that point, but looks like we can see the whole lot. Okay, so this is where these people that think the Earth is flat, they're saying that how can we see that island in this particular example when the horizon, according to the Earth Curve Calculator, at a height of 8 feet should be only a little bit more than 3 miles away. And maybe some of you have never thought about that, but 3 miles or 3.5 miles isn't really that far away. We see things that are beyond that every day if we look out on the ocean. And when I say see things beyond that, we can see water beyond that point. That should be the geometric horizon. But we can see the water beyond 3 miles away when we look out on the ocean. But in this particular case, we can see this Amity Point, which is like a landmark there, and we know the topographical height there and everything, and we can still see it where it should be behind. It should be, we should only be able to see the tippy tops of something that's over 16 meters high, but we can see that whole thing. So that's kind of like interesting, because the question is, okay, and look, space is a mystery. I'm not saying anything about that in this particular video. We do know that there's a bit of shenanigans around. They're landing things on Mars with parachutes, and they've got choppers, and we thought Mars didn't really have an atmosphere, and how do you use a parachute if there's no air and things like that. Like, some of us are a bit suspicious about the moon landings and all that type of thing, and but we're not talking about space. We're just talking about the 12.5 miles in front of my eyes here, and it looks to be flat. And the question is, how much Earth has to be flat until all of it's flat? Can you have a round Earth if 12 miles of it on water is flat? No, logically no. If the 12 miles is flat, well, the logical extension is that the rest has to be flat too. And that's just the argument that these flat earthers are making. So you can't blame them. You can't blame them when you look at evidence like this. Okay, so yeah, just thought I'd chip in there, because there is a bit of a thing where, just because someone thinks the Earth is flat, they get dismissed, and people just, think they're crazy and think they're subject to some sort of a psychological operation, and really don't give them the time of day sometimes, when they might know a bit about other things that are very important. But just because they see this little island here and it shouldn't really be able to be seen, and then they question the shape, okay, they get dismissed. And I just wanted to say, go easy on the flat earthers, because they're just looking at the evidence and they're just being honest with what they see. Anyway, until next time, peace.